Okay, so in this tutorial we're just going to go through how to set up a forearm twist. So adding in a forearm joint. So before we do, I'm just going to reset these rotates. I'm going to switch to FK and just reset this. And again, with having that naming convention, the last thing I'll mention is, because the names are the same, that IK and FK mel, to apply to the right hand side, all we have to do is either have a string for left and right that we can add in the code, so we can just replace left, all the left in the names to right, because the names are the same. And actually, just looking at this again, we've done a bit of an error, or I have, and we've got to always make sure, check these controls. So I'm just replacing right, make sure it's not capital. So this way they've got the same name, but just with that L and R switched over. So any mel code that we want to write for either of these controls, we can use the same name and just have a variable change the left and right. And it's the same reason that I didn't use the character's name. He's called Barry for this, so I've been saving it as Barry Rig, but I didn't put Barry_CC and then his name for every single control, because we're referencing this later on. But if I'd have called him Barry_ and then everything else, I'd have to include that in all the mel scripting. But keeping it all blank, I can apply this to all the mel to any rig that we're going to use, because they'll all have the same naming conventions, all the same names. Okay, so what I've done in this is, when we create this arm, I purposely didn't put in the forearm joint, because I've seen a lot of students, when making the arm, not putting that forearm joint, and they either start animating and they get a few skinning problems, or it's quite hard to skin around this area and they haven't got time to put it in, or they've found out later on they try put it in, or they put it in the wrong way, and it tends to screw up the rest of the arm that they've already made quite well. So I wanted to leave the forearm out so I can show you how to re-add it. So what we're going to do, and it's always best to add the forearm at the start, obviously. So if you wanted to add the forearm at the start, you can do. I'm just going to show you how to add that now. So first off, what we do is we delete the IK, because we don't want any problems with this IK. And before we actually delete it, we just want to have a look at what we've connected to the IK. So we've connected the translate, because it's blue, with a point constraint. So it's a point constraint to this wrist. It's pull vector constraint to the pull vector control, and we've got a set driven key on this IK FK blend. So I'm just going to take that all into notes, so I know what I need to reconnect up afterwards. So I'm going to delete that IK, and then I'm going to select the wrist and hit Shift P to unparent. So all we're going to do is we can add a joint in the middle of here, and we want to add it probably halfway through, because if you get your arm now and it's like you put your arm on the table, so your arm is on the table and your forearm is pointing 90 degrees up. If you twist your forearm, so twist your hand, you can see that your actual arm is not moving because it's on the table. You can see your wrist is actually twisting, and that's because there's two bones in your forearm that allow your arm to twist. So in rigging, we just usually use one bone, because it's not necessarily to add two, but we just need to add that twist in there, so all the twist happens in the forearm. So what we actually want to do is add a joint in there. So I'm just going to show the grid snap, and press enter to just create one joint on the grid. And what I'm going to do is select the elbow B, select the wrist control, shift select the new joint we've just made, and go to constraint, point. But in the option box, I'm going to kind of uncheck maintain offset and hit apply. And what maintain offset does is it basically maintains that offset, so it keeps its position but constrains it. If we uncheck that, what we would see is, if we just selected one joint and then the second joint point constraint, it snapped to that joint there. but because we've added 2, it's going to snap to both of them, so it's going to snap exactly in the middle. So this is a quick way that we can sort of constrain something to the exact midpoint, because I want to keep these on a straight line. So I know that they're perfectly straight now, so what I can do is, in the outliner, just press F to frame it. So it's at the bottom here, and I'm just going to delete the point constraint. So we've deleted the constraint, but it's kept it in the same position, so I know that this is exactly in the middle. And then all we're going to do again is re-link this joint chain. So selecting the wrist, select the new joint, P for parent, select the forearm joint, the next joint, P for parent. And I'm just going to copy the name, paste it, so joint BN left, and this is going to be the forearm twist. Okay, so we've got that made. So before we actually start doing anything with this, is we want to check the local rotative axis. So remember, display, transform display, local rotative axis, or add this to your shelf because we're going to be using it a lot. And I'll do the same, so hitting G, repeating the last command, I'll do the same with the previous joints. I'll just zoom in to the top. And it looks like it's working, but if we zoom in a bit more, or get to a good position, we can actually see that the X is not pointing directly down this axis, it's still pointing with the world. And as we twist, so another way to check that is if we get the rotate tool, pressing E, left click, local, or you can get that in your tools. I can see that the X is not pointing down. So if I was to twist this, like you would be twisting your arm, you know, twisting your arm like you did on the table earlier, we're not pointing down this, so we're actually, this will be actually breaking. You can see this bone is now bending, so that would give the appearance of the arm breaking, which is not what we want. So what we need to do here is we need to orient this. So in animation we can go to animate, skeleton, orient joint. I'm just going to reset the settings, and the only thing we want to change, these default settings work for our orientations on this, so if you use a different orientation, feel free to set up what you chose earlier. But I'm just going to uncheck orient children of selected joints. So basically this means if we had this selected, it would orient the children below, which are these joints on the hand. But because we set these up earlier and we're happy with them, I don't want to edit any of these joints down here. So I'm just going to select that joint, uncheck orient children of selected, and hit apply. And I can see now that that is aiming down the arm. So now if I was to rotate this, you can see we're getting that nice twist, but the arm isn't bending, which is what we want. Your forearm cannot bend, it's a solid cylinder, so it's two bones, two cylinders, but it can twist, so it can rotate. Okay, so I'll hide the local, actually I'll leave the local rotative axis up at the moment. So the next thing we need to do is we need to add that twist in there. So what I want to do is, we're only twisting in the X, so to make sure I'm going to lock the Y and Z, go lock selected. Now I said earlier that I wasn't going to lock the forearm control curve. I wasn't going to, even though it only rotates in Y as a hinge joint, I didn't lock them because the animator has more control. But this is a case where I am locking them because it's going to be such a rare occasion that they do want to rotate the Y and Z to manually break this joint, that I'm going to leave that in there because that's probably never going to come up. Whereas the FK control, you might get subtle animation where it is unrealistic, so that's a case where you don't want to lock it. So locking this means I know no matter what, we can only ever twist this joint. And all I'm going to do here is select these two joints, go to Windows, Rendering Editors, Hypershade, and we're going to do a similar thing we did earlier with the splitting the rotates between these two joints. I'm just going to go to the creation, type in mul for multiply divide, create one of those, just expand this work area. So I'm going to select the forearm, the wrist, go to graph, add selected to graph. And all I want to do is, basically, if I rotate this wrist 90 degrees, so you can get your arm on your table again if you want, and rotate it 90 degrees, you are rotating from the top, and you can see your forearm is rotating all the way down to the elbow. So that twist is distributed through your whole arm. So because this is at the bottom, what we want to because this is halfway through the arm, it wants half of the rotation. So we'll select the wrist, middle mouse click, drag and drop. Let's go to other, and I'll put all the rotate. So find the rotate into input 1. And once this is still open, I'm just going to select the multiply divide, reload left, select the forearm, reload right, and just take the output and we rotate in X, so output X, rotate X, and close. So we've just set it up so the rotations go into the multiply divide. It does its function and spits out the value to the rotate X of this joint. So now we'll set up the multiply divide, so we'll multiply, and again 0.5. So we're multiplying by half, so we're halving that value. And just to check that, and because rotating this control isn't doing anything at the moment, so what we'll actually do is select this control, select the joint and go to constraint, orient, and I'll just make sure maintain offset's on and hit apply. And in here you can see it's working, so you can see it's rotating and it's getting half that rotation, but we're getting an annoying message down in Maya, and you can see in some areas it's wiggling a little bit like there, so it's not rotating perfectly. So if we check the error, so one thing that you want to do is whenever you get an error, just don't get annoyed. The error's there telling you what the error is, so we just want to read it, and it says cycle on joint left wrist, parent inverse matrix may not evaluate as expected. And basically what this means is whenever it says cycle, it means that a cycle's happening, and the cycle of this, so if I just reset this, I'll just undo a few times before we made that orient constraint. The cycle of this is this joint here is the parent of this joint, but this joint is telling this joint to where to rotate. So if I rotate this joint in X, it's telling its parent to rotate in X, and if this parent rotates in X, it's telling its child to rotate in X, and if this rotates in X, it's telling it, and you get that cycle going on. And we want to avoid these as much as possible because it can make your rigs flip out or break. So what's actually happening here is we've got this cycling here, so you can actually see it. The rotate is going down at the multiply, and then the output of the multiply divide node is going into the joint, and then it's going along this arrow here, and we've got that cycle set up. So what I actually want to do is select the multiply divide node, so select this multiply divide node, select the X, Y, and Z, and I'll just go right click, break connections. So we'll just get rid of this wrist joint, it's not sending any information into there anymore. So we could actually just go graph, remove selected from graph. And so we'll reset that orient joint up, orient constraint, so select the control, select the wrist joint, constraint, orient, let's hit apply. So that's rotating now, it's working how we expect. So because the wrist control is rotating the joint, so what we can actually do is just get this control to rotate the forearm twist, because this control has no influence, it's not in that loop between those two joints, so this is outside the loop. So if this controls the rotation, we're not going to get that cycle error, hopefully. So if we go to graph, add selected to graph, let's go drag and drop, to over. I'm going to take the rotate and put it to the input 1. Hit close. So now we can see we're rotating this. That forearm joint isn't sort of jiggering about, it's rotating smoothly. We're getting no cycle error. So just by reading that error, we can debug it and see what's happening. And now we can see rotating this, so rotating 90 degrees, we can see that this is now rotated 45 degrees. So if this was skinned later on to the character's arm, we're going to get that smooth forearm twist, which is what we want, what we expect. Set this back to 0. Okay, so now we've got those set up, we're quite happy with them. So what I'm going to do is just hide the local rotative axes again. And we'll re-add the IK. So I'm going to select the IK, bring up the tools just to check that it's on rotate plane, and then I'll click, and this is the area where we don't want to follow along what we did with what we've just done. We don't want to click on the wrist because we've added this middle joint in here, and we could add it to the wrist because we have locked the rotate Y and Z of this joint, so there shouldn't be too many dodgy rotations going on. But it's always a bad practice, in my opinion, to have a joint in the middle of this IK and then lock it, because the IK is going to still be looking at that joint even though we don't want it to. So a better way would be actually to start from, oops, I'm just going to press Y to reactivate IK, so we start from the arm and end on the forearm. So that way we're still getting that bend, and we only want to bend on these two joints, so we're getting the exact same bend as we did before. The only downside is now the IK handle is on this forearm joint, which we don't want. We want it to be up here so we can point constrain it to this control and use this control. So if we bring up the Hypershade again, and basically if I graph the inputs and outputs of this connection, you can see what we actually have is the joint, the IK handle, and the IK RP solver, and this effector. And what this effector is basically the point of this handle. So this is the actual, when we look in the viewport and we see this handle here, we're selecting the handle, but the actual point of where this handle is the effector. So if selecting this effector, if I go to insert, so if I press insert to get the pivot point, and I can hold down V and vert snap it to this joint, and I press insert again to come out, and you can see now that the IK handle is on the wrist. And I'll just close the Hypershade. So the IK handle is where we want, but it is still evaluating from the forearm joint. So it is just bending these three joints, these two joints in the middle. It's not using this. It's using this as the end joint, and this is the start joint, and these are the two joints it can bend. Whereas before, if we'd have used the IK from the start to the wrist, it would be using all three of these to calculate the rotates of the arm. So just by ending it on the forearm, we are telling it not to use the forearm as the bend, which is what we want. So now we can just go ahead, select the control, shift select the IK, constraint, point. Oops. Select the pole vector control, select the IK, constraint, pole vector. And it's important not to move these controls when we're constraining stuff up, just so we know it's all in its default pose. And again, we can go to Windows, render it as Hypershade again. And I'm going to be using the Hypershade a lot because I love node-based things. Anything node-based, it seems to be really intuitive. It's just this inputs to that, and it's just a graph of how things work. So for me, for rigging, this is the holy grail of rigging. It makes perfect sense. So what we can remember, that IK-FK blend actually was red, so it was keyframe data, which was a set-driven key. If we remember, we also connected this control to the same set-driven key, So if I select these two, the IK and the control, just graph both those networks, and I'll move them along, and we're looking in here for the graph, which is, and we named it as well, so we know IK rotate plane, left arm, IK blend. So again, naming conventions are really useful. And I can select these and go graph, remove selected from graph, which just hides them. And then I can reconnect this up, so I'm going to right click on the bottom right corner, go to output, then left click on the top left hand corner and go to the IK blend. And I can just close that. And I'm just going to leave this here for a sec before I close it. And we can see here, it's, oops, on the IK it's been connected up again. So if I just move this out, the IK FK blend is working again. And we're getting that snap in with the arm, but again we're not using the mel script at this point, so later on when we do use that mel script to switch between IK and FK, it's going to be seamless again. But we can see it's working, it's following one or the other. So that's a way that we've just, because I've seen students have a lot of problems trying to fix something. So this is adding a joint to an arm that's already been set up with IK and FK and had the IK FK blend put in. So a lot of students, when they add this joint, they come across quite a few problems. So I just wanted to avoid adding that in at the start, just so we could go through the process of how we can easily and carefully disconnect this, set that joint up and reconnect it. So with rigging, it's not advised to go back, it's always best to, you know, think ahead, think at the start, I need a forearm twist joint, and add it in from the start. But this is just to show that you can go back, and if you do it in a correct way and you keep everything, we can add that in. And one last thing, I'm just going to graph that joint again, select the multiply divide node. What we could actually do here, so I'm going to select this wrist and go to edit, add attribute, and I'm going to call this forearm twist, forearm underscore twist, and give a minimum of 0, maximum of 1, and a default of 0.5. So what I'm doing here is adding an attribute to this wrist control of a minimum of 0, maximum of 1, default of 0.5. So if I add this, now what I can actually do is if I drag and drop this on the multiply divide node again, go to other, I can take this forearm twist and put it into the input 2. So if you remember, the input 2 is taking the rotate, dividing it by 0.5, so half in the value. But now, so I'll just display the local rotative axes of these again. So now if I rotate this joint 90 degrees, because we've connected that forearm twist up to a custom attribute, what I can actually do is I can choose how much I want to divide it by. So if I set it to 1, they're both going to rotate 90 degrees. Set to 0, this joint isn't going to rotate. Set to the default of 0.5, and we're going to get that smooth rotation. So this is a way that later on in the animation we're going to leave it as default 0.5, but in some poses it might look a bit too stretched or a bit too static. So that way we can just finesse that pose, we can twist it as much as we want. So it's just adding in that extra control for the animator, so they can easily just edit that twist. Okay, so in the next tutorial I'm going to go over how to set up this same the same forearm twist on the opposite side, again because I'm following this tutorial from start to finish. So if you're quite happy how that was set up, feel free to skip the next video. I'm just going to quickly go through adding the same on the opposite side